I wanted to talk a little bit about model quality tuning in SageMaker. This is something that I think is one of the strengths of SageMaker and is something that is not only a strength of SageMaker, but is something that is very difficult to build on premises. Hyperparameter tuning it requires a large amount of resources for a short amount of time. There's at least one customer that I know of that prior to SageMaker bought 100 NVIDIA DGX1s in order to do hyperparameter tuning. That's a very expensive proposition and not something that we expect every customer to do. So I'm going to briefly talk about SageMaker since most of you were here for my last talk. I won't go into as much depth. And then we'll dive into what hyperparameter tuning is, why you would want to do it, why SageMaker is a great place to do that. So let's skip over the stack because you've probably all seen it by now. And then skip to the customer story. So another customer that we've seen that is very happy with SageMaker is Hotels.com, which is part of Expedia. And they are interested in ways to move faster. They have a lot of machine learning problems. And Matt Fryer, who's an amazing chief data scientist over there, he's very interested in making sure that they're able to not only do very sophisticated data science, but able to do it at the scale that Hotels.com operates it at. And that's part of the reason why they've been looking at SageMaker, and Matt has been pushing us to create a set of features that allows them to do things like hyperparameter tuning and much more sophisticated data science techniques in a way that's compatible with their operations. So what is hyperparameter tuning? Essentially, you have this set of parameters that dictates the way that machine learning algorithms work. It's things like learning rate and so on. And those have a trade-off between the speed of training and the accuracy of training. And in some sense, this is truly important because if you select, if you bias all the way towards accuracy, for instance, you could have a model that ends up never converging as a result of that. Or if you end up saying, well, I really want results really quickly, and I'm going to select go all the other way for speed, you may end up with oscillations and a very unstable model result that doesn't have the accuracy to meet business goals. So essentially what you want to do is you want to select this tuple of hyperparameters that is able to make the right trade-offs in order to minimize the loss function in the amount of time that is appropriate for training your machine learning model and is able to meet your business goals. So how do you actually find those tuples? One way that people do it is they do grid search. They say, well, you know what? I can't think of a better way to do it. So let me just explore the entire hyperparameter space. And this illustration has 2 dimensions. It's usually more than that. For instance, for XGBoost, there's 9 parameters that people tend to adjust, which means that you end up with a 9-dimensional space in which you're exploring all of these parameters, which, if you think about the cost of that, that makes a $1 training job end up costing $2 million, which is crazy. This is an almost untenable way to do hyperparameter tuning unless you have a data scientist that's really picking and picking specific regions of the hyperparameter space in which to explore. A second way that people have tended to look at hyperparameter tuning is they said, well, you know what, grid search is a little strange and is probably not the best way to make sure that we have adequate coverage. So let's try random search. And random search is one that has ended up being a little more efficient than grid search at covering the space because there's no sanctity about those grid points, and you end up having additional coverage in certain areas, which helps the data scientist find the regions of interest. And you can usually do a little better than grid if you do that, but you still need a large number of tuples in order to do well. So you more or less haven't really erased that $2 million problem. You've gotten it so that that $2 million has better results. So how do we make it so that we're actually addressing that $1 training becomes $2 million? How do we address that problem? And the approach that we have looked at and are using in SageMaker is something called Bayesian optimization, where we basically view the objective function that you're trying to minimize in the case of a loss function or maximize in other cases. You're essentially trying to optimize that, and you're assuming a surrogate function that is based on the hyperparameters. So based on that assumption, you say, I think this is what it looks like in the two-dimensional space, and you provide these surrogate functions, and then you'll say, well, I'm going to run a set of training jobs and test the hypothesis, and then come up with a hypothesis that fits the data that I have, and then repeat that process over and over. So what does that look like? Basically, you start out with something that looks like this, where you've got, in this case, you've got 2 data points, and you say, well, I know the values in these 2 data points, and I think that the objective function lies between these limits. So let me figure out, based on that, where I should explore. And then you say, well, I'm going to explore that point there because I think that's where the objective function might be maximized. And then you take that and you run the training job and you say, okay, well, now I know exactly what that value is, so I don't need to guess what the value is at that point. Now I have a better estimation of the objective function in the hyperparameter space. So now I can figure out, well, what's the next best thing that I can test at? And then you pick that point, and then you do the same thing. And over the course of running these training jobs, you eventually have a better picture of what that objective function looks like in the hyperparameter space, and you're able to optimize over time. The other thing that you do as part of this process is you don't do a grid search in where you're running. You actually do a random search as part of this. So you pick a random set of points, and that random set of points feeds into your estimation of the objective function. And then the next time, instead of picking exactly 1 point to run, you pick a set of random points around that region, and you say, I'm going to explore the parameter space around there because I think that's a good region of interest. So you essentially have this stepwise process of narrowing in on a region that you think is interesting. And because there's a random component to it and you're not just picking 1 point, that means that you aren't as likely to get stuck in local maxima and minima as you otherwise would. Can we do better than Bayesian optimization? Possibly. This is an area of continuing research. We actually, the Amazon team that worked on hyperparameter, the hyperparameter tuning system that we have in SageMaker, actually published a paper on adaptive Bayesian linear regression. So that was published last week, I think it was. So this is an area of continuing research. There's also some really exotic approaches that people use, like genetic algorithms and so on. So maybe there's a possibility that you can do better, but in practice, it seems like most of the approaches that are out there right now that have shown to be really good are based on Bayesian optimization. So because of the time, I'm going to kind of really quickly go over the demo and show you what it looks like to do hyperparameter optimization in SageMaker. Essentially what you have here is I'm setting up the training job, and then when you set up the training job, instead of skipping over where you would explore the data as part of the process of setting up the training job, and then you would, instead of setting up the estimator as a single set of hyperparameters, you would actually provide ranges for those hyperparameters. And then let's see if we can find this is essentially the ranges that you would provide. So there are certain hyperparameters that you would fix, and then others that you would provide as continuous or discrete ranges. And the hyperparameter tuning will actually optimize on the basis of that. And this example notebook for doing hyperparameter tuning is actually available if you just start up a notebook environment. So that's something that if you look at the brain on the left, there's a set of examples, and hyperparameter tuning is one of those examples. So if you would like to explore it in detail, this is something that you can essentially run yourself through your account. But the result of that is that you have this distribution, once you run it, you have this distribution of what it looks like, the objective function looks like in the hyperparameter space. So this is a graph of max depth, which is one of the hyperparameters that we explored. And you can see that there's maybe some effect of max depth on the objective function. And then versus eta is maybe flat, not necessarily a fruitful area. Minimum child weight is probably not. But essentially, you end up with this graph of areas in the hyperparameter space that Bayesian optimization looked at and thought was interesting. And you have the results of each of those training jobs that you can go back and look at and guide further exploration. So how does the model tuning in SageMaker work? I kind of briefly glossed over that demo. Essentially, it works very similarly to SageMaker training jobs. So instead of providing specific values for hyperparameters, you provide these ranges of hyperparameters that you want the algorithm to explore through. You have full control over the entire process. You specify the objective function, you specify the hyperparameter ranges, but we're providing you with tools that allow you to automate the process of spawning out these training jobs. You can also minimize the cost by saying, I want the training jobs to only run this certain amount of time. I only want this many training jobs. I don't want, you can specify anywhere between 10 or 100 or 500 training jobs. It's all up to you. And you can choose the level of parallelization also. And probably the most important thing here is that this will work across all of the frameworks, across all of the algorithms that we provide in SageMaker, as well as the algorithms that you would bring to SageMaker. So as long as you're emitting the metrics for the objective function into log lines, you provide a regular expression as part of hyperparameter tuning that allows us to identify which metric that we need to optimize on, and we'll do Bayesian optimization on that, which means that you can bring your own IP and you can do hyperparameter tuning on your own algorithms, which is something that most systems don't really allow. And because it uses Bayesian optimization, it's pretty cost efficient. Within the last couple of days, we actually announced early stopping. So early stopping is another feature that allows you to cut short training jobs that weren't proving out to be very fruitful in their progression, so that you don't pay for the full run of training jobs where it's not useful. We also provide incremental tuning, which means that if you have past results that you used, if this is something that's you're tuning as part of a regular process, you can use the past results in order to inform future runs of hyperparameter tuning as well, which also allows you to minimize the cost. really, the power of being able to allow you to tune any machine learning algorithm is something that I don't think there are many other hyperparameter tuning systems out there that allow. Not only does it allow you to essentially have control over the entire process and run a lot of jobs in parallel, but it lets you do it with your own algorithms. And because of that, I think this is the only one that allows you to do it with PyTorch as well. So we were able to announce, even with the pre-release candidate of PyTorch 1.0, we were able to announce hyperparameter tuning on PyTorch 1.0 models. So this is something that allows us, whether it's built-in algorithms, whether it's marketplace algorithms, or any of these frameworks, or bring your own, you can do hyperparameter tuning on that. Let's see, we talked very briefly about that. And the workflow that we follow through with here is that once we identify the objective metrics and the tuning strategy, the hyperparameter system spins off a set of parallel tuning jobs based on the parameters that you specify. Supposing you specified 4 training jobs in parallel, you would be able to run those 4 training jobs in parallel and use that, the results of that run in order to inform the next set of runs. So that's essentially the workflow that we follow through. In general, there are some tips when it comes to model tuning. Categorical parameters are hard for model tuning to accommodate in general. Keep the search ranges reasonable. It's very tempting because of how well hyperparameter tuning works to just give it really, really big ranges. If you do that, there's a couple of problems. One is you may end up spending money in nonsensical regions where it doesn't really make sense for you to explore. And the other thing is you increase the chances that, depending on your degree of parallelization, that you would end up stuck in a local minimum or maximum. So it's, in general, better that you view this as a tool by which you can, as an educated consumer of this, so you can use hyperparameter tuning. It's not a complete black box. You throw anything you want at it and it'll come up with good results. And overall, there's a quality versus speed trade-off. You want to be able to control that and make sure that you're balancing the business needs. So I'm going to skip over this because of time, and skip over to questions, which I'm sure you have. Go ahead. Have I ever seen what? Network unlearn as you throw more data at it. I haven't seen that, no. It's possible for it, depending on how clean your data or how biased the data set was at the beginning. It may be that it actually learned a bias at the beginning. So if you actually feed it data afterwards, that it would unlearn some of the biases that it learned before. It's a little harder for it to do that, which is why most practitioners will do things like shuffle in order to make sure, or shuffle between epochs in order to make sure it doesn't learn the order of things. Neural networks are finicky. Do you have control of the breadth and depth of the network? Absolutely, because we don't provide a generic neural network as an algorithm. What we actually provide is multiple deep learning frameworks in which you can construct the neural network. Keras, for instance, if you use Keras TensorFlow or Keras MXNet, it's really easy to build the network exactly how you want. So you have control over everything, breadth, depth, everything. Other questions? Go ahead, please. That's a great question. Is tuning available in local mode? The answer is no. Unfortunately, tuning is one of those things that you really, really need to do in the cloud with the full breadth of instances available. So unfortunately, the answer is no. I'm looking at ways that we can potentially give some of the benefits of that, but it's really hard because you essentially expect that you have this vast pool of instances that you can tap into in order to take advantage of that. Like supposing my training job needs, it's relatively small, it needs a little bit of parallelization. I'm running 3 instances in parallel, but I really want to do hyperparameter tuning, and I want to, let's say, run 20 jobs total, 5 in parallel. Essentially, I'm asking for 15 instances in parallel through the entire training process. I mean, this is really the kind of workload for which the cloud was created, because you want the instances for the period of time when you're hyperparameter tuning, and then after that, you don't want them. So it's really a workload that is well suited for the cloud, but given the question, I will do my best to figure out a way if we can provide some of the value in local mode as well.
We can experiment with the tuning, not on the full model, on the smaller model, and then we can move into the full model.
Yeah, I mean, it's certainly, it's certainly something that I'll look into. I know a lot of customers are interested in using local mode in various ways, and that's one that I'll take that feedback to try and figure out what we can do there. Go ahead. Yes, tuning is available in all regions that we've launched in. In general, I try and make sure that all SageMaker features are available everywhere. It's only a few of the newest ones, Elastic Inference, Ground Truth, Neo, I think are the 3 that are not available everywhere. Everything else should be available everywhere. Go ahead.
So, these hyperparameter ranges that we have to specify, right?
Yeah.
They are quite limited when it comes to algorithms like SVMs or decision trees. But when it comes to deep neural networks, the amount of parameters that you can find is explosive. So is there a specific thing on how we supposed to use these hyperparameter ranges for deep neural networks?
Got it. So the question was, how do you determine the hyperparameter ranges for things like deep neural networks, essentially? I think that's part of why I was cautioning that it's not a black box that you kind of throw stuff at it. It's still something that I would characterize as a tool for experts. Machine learning is pretty hard, and I don't think we're at the point yet where we can say everything will work magically if you just kind of throw things at it. This is actually something that takes experience, and it takes a deep understanding of the data as well as the methods in order to do that. So this is more, like the way I would characterize this is, it's more a way that a data scientist can be much more productive than something that would enable someone who doesn't know data science to be able to do this.
So generally there's this whole notion of where the first 2 layers learn to generate, and then there are enough layers which tries to estimate how the network. So is there a way to set, unfreeze all the gradients in the final 2 layers and then keep only 2 layers floating? That's kind of fine tuning.
Got it. So the question is more around the process of freezing certain layers and generalizing and tuning on the last few layers. You can certainly do that. You can certainly do that, but what I'll say is it's not a process by which, it's not a generic process. So you would actually have to do that through training the first few layers using the framework of your choice. We'll say TensorFlow because it is for most people. So you train the first few layers, you train the generalized layers first, and then you freeze them, and then you run another set of training jobs with the last few layers, and then you can hyperparameter tune on that. But essentially, it's the flip side to it's under your control is you have to do it, And that's something that we're trying to find a good balance between it's under your control and you have to do it. And until now, or up to now, we've viewed this more as something that data scientists need to have the right tools that they can use in order to do this. But it's certainly an area that we're exploring, and we're trying to figure out what the tool set that we need in order to make that kind of process easier. It's not an area that we have spent a whole lot of time on optimizing the deep neural networks themselves.
At this point, it's much safer to assume that it's much better to control the config memory.
Pardon me?
So it's much better to use a config to control all these stuff and then use the normal training job to get this.
Well, you could use the normal training jobs. I mean, there's nothing. You can still use hyperparameter tuning to do exactly those same things. It's just that you have to configure things in order to take advantage of hyperparameter tuning in that way. So it's not something that's automatic. It's not like you can create this neural network in we'll say, Keras, right? Like you create the neural network in Keras, and then you say, these layers are the ones that I want to tune. That's not something that's built into SageMaker. SageMaker basically says, okay, you tell me what you want to tune, and I'll tune that. It doesn't choose what to tune at this point.
Essentially, it's basically cascading through the model.
It's not even cascading to different models. It's more that you're doing two different training jobs in order to optimize different parts of the model. And if you were to operationalize it, the way that you would do that, you could do that, is through something like step functions, where you run the training job on the first part of the model and then take that state and pass it to the second part, and then run the training job on the second one, and then do hyperparameter tuning on that second one once you have it fixed. And it is something that you could do, and it's probably the way that most people would want to do it at this point. Frankly, if you think about the state at which machine learning is right now, the way that you could solve that is you could say, okay, yes, I'll tune it for you, I'll do all of this for you, and I'll fix those layers and do it. But the result of a naive approach to it is it becomes more expensive. And the reason that we built Bayesian optimization, we built Bayesian optimization on purpose, and we went out there with Bayesian optimization, and then customers said, but what about grid? And what we've shown to customers that say, but what about grid, is that the cost of Bayesian optimization is actually lower. We're trying to be careful about what we build, because machine learning is one of those things that can get really expensive really, really fast. And if it gets that expensive, no one's happy. I mean, that's not the way that we want to make money. We want to make money by providing services to you in the same way that we would provide services to ourselves. We're naturally looking at ways that we can be frugal and provide low-cost ways that you can come up with the models. So probably a longer answer than you were looking for, but essentially we're trying to find a good solution that allows you to do these things very frugally. Go ahead.
Part of the service, does it also provide a recommended parameter which is found by this job?
Does it provide the recommended parameters? No, not yet, but that is something that I would really like to. Oh, does it provide the recommended parameters at the end of hyperparameter tuning? Yes, absolutely. In fact, let me. Am I still on? Okay. Let me flip over briefly to that, because that's actually a really good point. It provides all of the information. So it provides. Oops. Somehow I'm not on the screen. There we go. So you essentially have all of the data for all of the runs. It has the objective values. It has all of the parameters that it explored. I kind of briefly ran through the demo, but essentially it has all of the data available. So you can create a leaderboard based on that. And you can even look at past results. So not just of this hyperparameter tuning run, but if you run it weekly, you can see what the progression of it looks like week over week and so on. All of that information is available. Go ahead.
Well, I wanted to understand what is it, once we deploy this model
Mm-hmm.
in production, what are the feedback mechanisms we have to understand how it was being utilized by the business?
Got it. So the feedback mechanisms, once it's deployed into production, at least at this point, you're building it yourself, because the truth of it is something that we don't have a good understanding of what the truth of it is. That truth, you can use the ground truth service in order to provide human-based labels, if that's something that you have. There are some systems that inherently have the truth in them, like ad clicks, those systems. If someone clicked on an ad, you know the truth right there. Or recommender systems, if someone took a recommendation, you know the truth. So those truth mechanisms exist. We also provide a file format called augmented manifest that allows you to take that truth and build it back into training data. But the full loop of going from truth back to training is something that is a little bit more manual than I would like. And that's something that we'll be working on trying to figure out. I mean, that's something I'd like to make it a little easier than it is right now, because there are more advanced things that I'd like to do there. And that's an area that I would love feedback on for how we should do it. Because how we make it so that you can give SageMaker the truth that it uses in order to train further is an essential part of completing that loop.
I think that's where the value comes in.
Mm-hmm.
Value is understood from there. Because what I feel, a lot of these models are, after the extent that the value adds are very, very, very good.
Yep, no, I totally agree with you. There's a lot of value there. It's one of the reasons we built ground truth, is because for certain problems, providing a human-based workflow that allows them to identify truth is appropriate. But there isn't a uniform way that we have to inject truth into the system yet. Go ahead. How do you decide the initial number of training job? Is it you as an individual or SageMaker the system?
So for the Bayesian model,
Mm-hmm.
you first launch some number of jobs to decide what parameters to train on it.
Mm-hmm.
Right?
That's correct.
You decide how many jobs you might want to spread it next year.
So the number of jobs, the parallelization, is actually determined by it's one of the parameters provided when you call it. So SageMaker doesn't determine the number of parallel jobs. That's something that you would provide as a parameter.
That number can essentially determine what kind of
That absolutely. So it's very it is sensitive to that parameter, and that's another thing that relies on the data scientist's expertise. So depending on whether accuracy or speed is a trade-off for you, depending on where on that trade-off, you can either choose to have more jobs in parallel and get the results faster, or you can choose to have fewer jobs in parallel and get more accurate results for the same number of training jobs. But that's essentially the trade-off. One last question, and then I probably have to go, but I'm happy to answer further questions outside. Go ahead. Mm-hmm. It required what?
Specific API, for TensorFlow, if I was only allowed to use the SageMaker API,
Mm-hmm.
can I use a custom API and custom code?
So can you use custom code to get predictions? Absolutely. It doesn't require the estimator API to get predictions. No, it actually doesn't. That's the examples. So we have a set of examples that use the estimator API. The estimator API itself is actually, we built that in order to make it easy. It doesn't require that. There's actually a lower level API that's the Bodo 3 API that you can use from Python, or you can use anything in the AWS SDK. Or if you want to write your own, it's essentially a REST endpoint. So as long as you can handle the auth stuff, you can just address it as a REST endpoint. At one point, I actually wrote like AppleScript, an AppleScript application in order to access those. And there's no SDK, there's nothing. I just accessed it directly. So this is, it's totally possible to do. There are some examples that describe the low-level API. So you should be able to find those examples in the notebooks if you look, or if you want, in the GitHub repository that has SageMaker examples, whichever is convenient. Awesome. Well, thank you all for sticking with me, and I appreciate the time. I'll be outside to answer questions if you have more, and if you have other things that you'd like to discuss. Thank you.